Chatbots and agents are often spoken about like they are the same, but they are not. There is a lot going on under the hood, such as calling tools, planning out multiple steps, and so on. But take all of that away. There is one thing actually separates an agent from a chatbot, and that's memory. There is an actual framework for how agent memory works. It came from a paper called Cognitive Architecture for Language Agents, or COALA. It came from Princeton research team, and it breaks down the agent memory into 4 different types. They are working memory, semantic memory, procedural memory, and episodic memory. Okay, hearing the names might sound complex, but let's understand them with a story. Let's assume you're stepping into a meeting room and there is a mid-sized whiteboard in the room. Now your meeting started, various decisions are happening, and everything is written, drawn, and sketched on the same whiteboard. After some time, the whiteboard got filled, and in a flash, somebody erased that whole whiteboard, and nobody took a copy of that. Okay, that's scary, right? Now let's apply this analogy to the chatbots and agents. That whiteboard is your context window. Your chatbot or agent can remember everything you mentioned in that conversation. It can be audio files, video files, or normal text, and so on. Just like the whiteboard in the example, the context windows also comes in a different sizes. So the smaller is the context size, smaller the conversation you can have with a chatbot or an agent. Once it's filled, you have to start a new session, meaning the whole conversation, the whole memory is lost. The memory it holds in the context window is called the working memory. You might have gotten a doubt, just like I had. Why don't we just increase the context window? Yeah, problem solved, right? Good idea. Why don't we just test it? Let's continue the same example. Now, the same meeting room, and the whiteboard is upgraded to a larger whiteboard. Just like the context windows right now have 1 million tokens. For example, you might think like, yeah, the problem solved. We can continue the meeting. We can have the longer conversations and the problem solved, right? Actually, no. Larger context windows have a problem. Let's continue the same meeting. Now you have a bigger whiteboard, so you can write as much as you want. So the meeting went on for 2 hours and 75% of the whiteboard is filled, and you can still continue the meeting for another hour or 2. But can you remember everything discussed in the 2-hour meeting? The answer is no. You might remember some important elements which you might think important, and few additional elements. That is the exact problem with working memory as well. Your agent or chatbot cannot remember everything you mentioned in the context window. That is explained as a problem called lost in the middle. Meaning, if you have a longer context and longer conversation, so somewhere the chatbot or agent will remember the start and the end, but somewhere in the middle, it will mix the nuances. Hope you understood the working memory now. Let's move to the next one, semantic memory. Let's stay in the same meeting room for a second. And someone in the meeting asked like, how many casualties we get this year? That's not something anyone going to write on a whiteboard. Also, it's not something which you get erased meeting after meeting. This information sits in the company's handbook. HR updates it once in a year and defined as standard guidelines or rules. That handbook, which defines standard guidelines and rules, is your semantic memory. It holds the durable stuff, company facts, project rules, documentation, conventions, the kind of stuff which doesn't need to re-explain every time. Now, you might be thinking, why don't we just write the whole handbook to the whiteboard at the start of the meeting every time? Because that would eat up your whole entire whiteboard. On the enterprise side, that's usually a vector database doing retrieval augmented generation, fetching just the handful of facts instead of the whole handbook. But you don't need anything that fancy to see this working. My own setup works on the same principles. There is a file called about.md which sits on the root of my browser, and every single session, before it doing anything else, this is the file it reads and understands. There's a second file, memory.md, where facts I have told it to remember actually live. So 2 files doing the work of a semantic memory for me. Hope semantic memory is clear now. Let's get to the next one, procedural memory. You open the process documentation, find a specific how-to for raising a purchase request, you follow the steps and you submit the request and it's done. That's procedural memory. How you or an agent actually executes a task. On the agent side, the version of the specific how-to page is called skill. A folder with a file inside it, usually named skill.md. And it will get opened when the task in front of the agent actually matches it. Here's why that matters. If the agent loaded the full instructions every time the agent is working, whether if it is related task or not, it will unnecessarily load up the full working memory or your whiteboard. So instead, it keeps a lightweight index upfront, the name and one-line description of what this skill actually does. And it only pulls the full instruction list only if the agent matches that particular description. That's called progressive disclosure, and that's the whole trick behind it. If you are finding this useful, please give a thumbs up and hit a subscribe. Hope procedural memory is clear now. Let's jump to the last one, episodic memory. A few months pass, a client came to negotiate a deal which he had already discussed with your team a few months back, except the employee who actually worked on the deal moved out of the team. So whoever is in this meeting are hearing them for the first time, and they are going to consider this as a fresh request, and from the client's point of view, it is kind of awkward. That's actually the right way to think about a new chat or agent session too. Every time you open a new session in an agent, it behaves like a new employee working on the project. Doesn't matter how many times you talk to it last week or the last month. Every new session, this session doesn't have any memory of it. Its working memory starts completely empty every single time. So how does the mistake not repeat? Because somebody wrote it down. A quick note in the shared documents from the 6 months ago. It mentions, okay, what client has asked and what we say to them. Whoever is in the meeting right now will check that note, understand, okay, this is what the discussion has happened, and they can continue from there. Even though they personally have zero memory about the original conversation, they are not starting from the scratch. That log, the one connecting a brand new session to everything that happened before, that's episodic memory. Not the handbook, that doesn't change, this does. So you doesn't cold start every time. The naive way to build this is save every call transcript in full. But nobody will read 300 lines of transcript every time. So it turns out to be close to useless. The smarter systems uses something called consolidation gate. It's a cheaper pass, waits until the enough sessions pile up, then goes back and boils them down to one short durable fact. Like, the client has asked for a discount back in March and we have said no, and here's why. And there's a real problem hiding here too. Honestly, the hardest of the four to get right. Old notes go stale. People change team, exactly like in the example what we discussed. Officers move on, and at some point of time, the old notes become useless, or they become actively wrong compared to what we are doing now. Figuring out when to actually let go of an old note is something nobody has cracked yet. Hope episodic memory makes sense too. That's all four. I said at the start, we would also talk about when to actually use each one, because most agents don't need all four at once. Think about a receptionist who is welcoming the visitors to the hotel. So it is the same line being repeated to every visitor. No memory is needed beyond what's on the page in front of them right now. That's working memory and nothing else. It is a simple chatbot. Think about a help desk person who is helping customers about resetting the password. They're working off what's live right now, plus one specific how to of resetting the password. That's working memory plus procedural memory. That's a customer support bot that you would have talked to maybe 100 times. And then there is this person who is running this office for 2 years. They have got a process for almost anything you would ask them. And you bring up a client by name, they will remember what happened with the client in the past. So they're all four working together. For example, take a coding agent. So without even you babysitting them, they are doing almost everything end to end. So let's put it all back together. Working memory is your whiteboard. It's live right now, gone the second it's wiped. Semantic memory is the handbook on the shelf. Durable, pulled out when you actually need it. Procedural memory is the one page you actually need for the task in front of you. Episodic memory is the log of what actually happened, the reason why you don't make the same mistake again. A basic chatbot only has the first one. Everything past that is what actually makes something an agent. And if you haven't already, please check out the last video where we have discussed about 5 agentic that work inside an agent. I will drop a card right here. Tell me in the comments if you want to see full breakdown of how to build a skill or any other memory you want to understand. If this video helped you understand agentic memory, please do like and subscribe Walk the Tech. It will be really good motivation for me. I'll see you in the next one. Thank you.